Hey, Math 8, this is Mr. Bainey, and we're going to take a look at, hey, what's up, Math 1? We're going to take, hello, this is Mr. Bainey. Let's take a look at lesson 11.3, which is called angle-angle similarity. That's not what it says at the top of this worksheet, but we are going to be looking at similar triangles specifically and what we can do with them, what kind of properties we end up with. So similar figures, pretty much the same thing. You actually dealt with similar figures last year and also scale drawings. You're going to see that show up here in this lesson, but it's going to be sort of the same concept. So let's fill in some of these sentences with vocabulary words that you're going to come across in this lesson. So similar figures. So like similar triangles or similar quadrilaterals or whatever the figures may be, they have the same shape, but not necessarily the same size. Okay, so if you have a bigger triangle and a smaller triangle, they can be similar, right? But other things have to happen. Number two, the symbol that looks like this, like a squiggly line, that means similar. And this symbol we've already used in class earlier is just the notation or the symbol we use for angle. Number three, a scale drawing is an enlarged or reduced drawing that is similar to an actual object or place. You know, think about if I asked you to draw a picture of the school, or if I asked you to draw a picture of your home, right? If you're drawing it on a piece of paper, your home or the school is much bigger than your drawing. So we call that a scale drawing. And also it has to be to scale. And that means if you're drawing your home and your closet in real life, right? Your closet's going to be smaller than the rest of your room. So in your drawing, you're going to draw it so that the closet is much smaller than the rest of your room, right, in the drawing. So we call that drawing it to scale. Number four, when we have similar triangles, corresponding angles, we'll talk more about that word corresponding. Corresponding angles are congruent, right? Congruent means equal in measure. And corresponding sides are in proportion, right? They're proportional to each other. And to find the missing side length, I'm on number 5 now. We're going to set up and solve a proportion. And in math, a proportion is an equation that we can set up where a fraction equals another fraction. And the rest of this last sentence here says how we're going to set up our proportion. We're going to put the measurements of the smaller figure on top of the fraction, and then the measurements for the bigger figure on the bottom of the fraction. There's other ways to do this, but that's how we'll be setting it up and making our proportion, and then from there solving it. So let's look at how these angles and these sides correspond, and then I'll have you practice a couple of these, right? Knowing how these correspond is crucial to you knowing how to set up your proportions, because if you don't know what matches with what or what corresponds with what, you won't be setting up your proportion correctly. All right, as you can see, we have two triangles, ABC and XYZ. They are similar. So you'll see this is a similarity statement. And that reads, triangle ABC is similar to triangle XYZ. Right, that's our math statement. The way that this is written already shows you what corresponds. A, because that's the first letter, corresponds to X. That's the first letter, right? B corresponds with Y. C corresponds with Z. It helps that it's in alphabetical order too, but it's important that you understand the order of these letters. It has to be in that specific order. So in this picture, A and X correspond. Okay, so A corresponds with X. B corresponds with y, and C corresponds with z. Now let's look at the sides, and I'll be marking it on the picture as well. So side AB, this right here, is going to match, or it's going to correspond with XY. And another way you can tell is AB is the first two letters, XY is the first two letters when in the similarity statement. So XY, right? BA corresponds with, oh, this is trying to trick us a little bit because BA is actually the same segment. I'm going to do it in blue this time. But from B to A is this one, which means that it's this one. All right, so it's actually the same exact thing. I'm just going to put YX because they put it in that order. And then finally, BC is this bottom one of the first triangle. That's going to correspond to YZ. Now I'd like you to try the two practice problems down here before we move on. The directions here say that it wants us to label points D, O, and G on the small triangle. But as you can see, it's already labeled, so we don't really need to follow that. But we're going to fill in these blanks. I'm going to have you do it, and then we'll move on to the next part where we're setting up proportions. Go ahead and pause it right now while you try this. Pause it for, let's say, a few minutes, and then you'll see the solutions here, and I'll walk you through it. Here's a solution to the first practice problem. I didn't do the one at the end because I wanted to talk you through that one. But remember that we can look at our similarity statement to figure out that S and D match up, I and O match up, and T and G match up. And we can use the same process to figure out these sides from D to O that matches with SI, and so on. Suppose S equals 25 degrees. Now it's supposed to say angle S. In fact, let me add these on here. They, for some reason, didn't show up here on my end, and I should have included it on the top. I apologize. But this means angle A. I'm back up at my top example, and then angle X, angle Y, angle Z. So anyways, angle S is 25 degrees. So I'm going to put it here in our picture. Remember that on the very, very top, I mentioned that corresponding angles are congruent, or they're equal. They're equal, they're exactly the same. So if angle S is 25 degrees, the measure of angle D, well, angle S and angle D correspond. If they correspond, they have to be equal. So angle D also has to be 25 degrees. Okay, let me go ahead and put down the solutions for number 2. So H is going to, angle H, please add the angle there. I'm sorry, I missed that. Corresponds with angle P. Angle O corresponds with angle I. And angle T corresponds with angle G. Side PI goes with HO. Side IG goes with OT. And side GP goes with TH. Okay, so again, know which angles correspond to which ones, right? We always go from one triangle, we go from one triangle to the other triangle, right? One of the angles here corresponds to one of the angles here. The same thing with the sides. On the back, example 1. The figures in each pair are similar. So that means we have this similarity statement. So know what corresponds to what. For example, angle A corresponds to angle X, or side AB corresponds to side XY. Triangle ABC, that's going to be our small triangle. So when I talk about going from the small triangle to the big triangle, you know which one I'm talking about. And a triangle XYZ is our big triangle. So if I'm starting with a small triangle, what's one of the measurements in the small triangle? Well, we have two of them. We'll just pick one of them. So I'll pick 3. What does 3 correspond to, right? This is where the corresponding or the matching of the sides is very important. If 3 from the small triangle is this side AB, what corresponds to this side over here, right? AB matches with XY. So XY is question mark. We don't know what that is. Okay, that's going to equal, what's another side from our small triangle? Well, we know that we have angle, not angle, but side BC is 4. So I'm going to put 4. And side BC corresponds to to YZ. YZ is down here, which is 8. So I'm going to make that an 8. And instead of the question mark, I'm going to do this because I want to use a little bit of algebra to figure this out. Instead of the question mark, I'm just going to put an X there. It's the same thing. It's our unknown. So the way we solve a proportion is we cross multiply. I'm going to do X times 4. That's 4X, right? 4 times X, same thing. Equals, I'm going to do 3 times 8, which is 24. We call this cross multiply, and I only need to do one step from there. If I divide both sides by 4, I get X equals 6. Therefore, the missing side is 6. Okay, this is the algebraic way of figuring out that missing side. There are other ways. If you want to show some work and figure out a different way, totally fine. All right, but this is how we set up our proportion, and then we solve the proportion. Example number 2. This is the last one I'll do, and then you'll have your assignment. Okay, we don't have triangles this time, but it's okay. This works exactly the same in any shape. All right, these two are similar, and they don't give us any letters here, but I think it's kind of easy to tell that this side in red is going to correspond to this side. And then this bottom side right here corresponds to this other side that I have in blue. All right, so I have my small rectangle is what it looks like, and I have my big rectangle. So from the small rectangle, one of my sides is X, and that corresponds to 2.5 in the big triangle. All right, so I went from small triangle X to big triangle 2.5. Those correspond. That's going to equal, well, what else is from my small rectangle? I have 3 right down here, and that's going to correspond to 5 for the big triangle. So 5 goes on the bottom. So remember, my measurements for the small one go on top, measurements for the big rectangle go on the bottom. And from there, let's cross multiply. So I'm going to do X times 5, which is 5X. Then we'll do 2.5 times 3, and that is 7.5. Just one step here to get my answer. I divide both sides by 5, and that gives me 1.5. So that's our X. And that's all there is to it. This is all that you are really expected to know how to do in this lesson is to set up these proportions or to figure out these missing sides when we have two similar triangles or two similar shapes. I do want to show you how to get started on a couple of these because they're a little bit trickier than these examples. So go to number 3 where we have an X and a Y. So let me tell you which ones here are corresponding, just to make sure we're here on the same page. So from our small This looks like a trapezoid, but from our small shape, we have 3. That corresponds to this, to 6. Right? So that could be one of our fractions, would be 3/6. And then we can put that equal to y from the small shape over 4. And then you're going to set up a third fraction where from the small shape you have x, and from the big shape that corresponds to 12. So it's almost like you're figuring out 2 different problems or 2 different proportions you're setting up, right? But the 3/6 is what you're using multiple times. Okay, so in fact, I'll write the first one for you. 3/6, because 3 is from the small shape and 6 is from the big shape, is going to equal y from the small shape over 4 from the big shape. And then you just figure this out. You can do your cross multiply and then solve for y. And then from there, just, forget about all this and then set up a proportion where you can figure out what x is. Okay, so it's like you're starting over again. And for number 4, this one, just like number 6 as well, is a little tricky because there are 2 triangles here, but there's 2 like nested. Sorry, one is nested inside of the other one. So I'm going to draw these separately for you to make this a little bit more clear. So if this is our small triangle, that's this one right here, this one inside. That means this is W and the bottom is 16. Then if I outline the whole thing in blue, that's our big triangle. Well, what are the sides of the big triangle? I'm going to draw it again over here. Here's our big triangle. Well, the right side is 12. Think about this bottom side. This bottom side isn't 4, right? It's the whole thing, which means I have to do 16 and then plus 4, and that is 20. And it does give us some units too, which is nice. So centimeters. And we're going to use those 2 triangles. They are similar, right? Everything in here is going to be similar for us to figure out our proportions. And this is our small triangle. This is our big triangle. So I think from there, you'd be able to set up your proportion and figure it out. And you do pretty much the same thing for number 6. Okay, so the rest of this is your assignment. This is your practice for this lesson. Whatever you don't finish is for homework. And this does conclude our module. This is the very last lesson of Module 11. Okay, thanks for watching. I hope this was helpful. Have a good day.